Welcome to Sai Jani Academy channel. So this is the general purpose PCB. By using the general purpose PCB, we constructed the circuit. This is a RC coupled amplifier circuit. We drawn here by pen. The same circuit we constructed using the general purpose PCB. This is the rear side of the PCB. You can see the component. The same component we are matching with the circuit. So the capacitor is capacitor, resistor is the same resistor, this resistor, and this is the transistor. Center one is transistor. Then this is the capacitor and a resistor. One more capacitor for the output, and here is the resistor. This is the another circuit we call as full wave with a bridge regulator. Here is the regulator IC. This is the transformer and a bridge circuit. We have a capacitor, we have a IC 7912 IC. 7912 means it's a negative output. This is the inverting amplifier circuit by using the IC. This is also done with the help of the general purpose PCB. This is the rear side of the PCB. You can use the general purpose PCB for constructing the circuit, electronic circuit, at a small scale. Okay. So now how we will going to take the printout of the PCB layout, which is generated. We already discussed in the earlier sessions or earlier video. Now we are going to take the printout of that PCB layouts. So we are opening. We already done that PCB layouts, and I put in all in one sheet only. We constructed all the circuit in a single sheet only to avoid the wastage. To save the paper. Okay, this is the regulator circuit. This is a summing amplifier, a stable multivibrator, full wave rectifier, RC phase shift oscillator. This is SR flip-flop circuit. All the PCB layouts I put together in a single. I bring all these layouts in a single sheets, and I am going to take the printout with the help of the printer, laser printer, any laser printer, Canon, it may be a Brothers or any kind of printers you can use for it. Taking the printout. This is what taking the printout. You can move with the help of this symbol to bring it down. This is very important. The bottom layer we are going to take in the bottom layer. So we need to change that option. Here is very important. Silk. You remove this silk so that you won't get any other component symbols. Here you take it 100%. You can use this button for moving the things down or up, and for the printout, print that. It is asking which printer. OK. Press OK. I am using the Canon printer. So taking the printout. This is the printout. This is the printout we can get. This is the Canon printer. What are the material we required? This is what single-sided PCB. Kodak photo paper we require for taking the printout. This is a general copper clad. This is the copper clad what we are showing here. One side is copper is there, another side is only clad. This is the clad side. This is the copper side. You can draw this circuit on the Here you can place the components. Okay, these are the number of clads we have. So many number of clads we have for giving it to student. Photo print paper. This is the photo paper, we say, high glass. You can see this. This is a thicker one compared to other normal paper. This is FeCl3 chemical. This is for etching purpose. This is for etching purpose. The mixture of water and this ferric chloride, and this is a thinner. We need a iron box, we need a scrapper, transparent plaster, drill machines. Again, we required a AXA frame, small AXA frame we also require. This is again we are showing the same things. Once again, copper clad, photo paper. This is ferric chloride, thinner, iron bar, scrubber, transparent sheet, and drilling machines. Now we try to cut the required size. To avoid the wastage, we use a single clad for number of circuitry. Here is the example we are started doing that. Okay. Good. So the minimum wastage, we can't say fully we control the wastage by doing this way manually. Okay, using the scale and a cutter. Okay then. I am using this, I am putting all this circuit on copper side of the PCB. This is a copper clad, we say, not a PCB it is. Okay. So in this way we arrange the copper clad. Now what we will do is take a pencil or a pen and draw the required size for each circuit. Okay, this way. Yes. Now we need to cut it by using AXA frame. This is a small AXA frame, we say. Don't bend while cutting the this copper clad, else what will happen, the blade of this AXA frame will break down or cut. Okay. Okay, in this way, cut in a, yes, it may be not perfectly rectangle. Place this your printed PCB circuit by which is taken from the printer. In this way we are showing that. Okay. place in this way, plaster it using the plaster, white plaster, transparent sheets, we can say transparent plaster. Okay, take the help of with your friend. Okay, put it in this way. Now use the iron box with a temperature around 100 or 120, about 1 to 2 minutes. I think it is enough to get printed. It is now very hot, so this is a hot one. So what we have to do, we have to dip this thing in a clean water we say, for few minutes. Again it is wait for 30 to 45 seconds we say, else wait for another 10-15 minutes seconds more. Afterwards remove that transparent sheets. Okay, slowly remove it. This one here, yes, we can see the track is transferred, right? Good. Okay, now you can see this, clean this. Here it is not okay, somewhere it is missing the tracks. So what we have to use, the permanent marker, where you can find it is not clearly printed. You use that permanent marker. Now we are going to mix the FeCl3 chemical and water, 1:3 ratio it is. Okay, put it properly, make the solution, use the scale or plastic rod to mix that. All the time don't use a hand to mix it. Wait for 30 minutes, more than 30 minutes. Shake this water to generate the water waves, so that it will fast for removing that copper. Other than this track, everything is removed. Now you can see, other than this area, everything is removed. All coppers are etched. Now you can see the track. This is the clad, we can say clad it is. All coppers other than this track is removed. Clean that areas. Use this thinner to clean this black shade also. This is what are the thinner we are using to clean up this side. Use in this way. All black color is gone now. Almost you can see, yes, remove everything. Use the thinner to clean that. Okay, this is what we finally get. Now next step is we are going to drill the holes. Say we are doing the drilling. This is drilling machine, hand drilling it is. We are using hand drilling machine to make the hole. Carefully use a safety tool so that it should not hurt you. So in this way, holes, make the holes by using this drilling machine. Say in this way. Afterwards, you have to insert the component. So this is the component we are inserted. So here is you can see the bridge, the capacitor and the resistor, the circuit, the similar circuit what we are showing here. So diode is P type, it is a N side, this is a P side, N side, like this. We are connecting, inserting the components. This is the diode, we are making the bridge. These two pins are inputs and we are going to insert the capacitor now. Now finally we put the resistor. So this way mark the required yes. Now you can see this. This is the AC input, this is the load, these are the component. Just we have not soldered. Now it is a soldering process. Soldering process also you should be very careful. 25 watts soldering iron you have to use. This is the way you have to use the flags. Okay, nicely you have to put the flux over the track side of the clad. Okay, afterwards what you have to do, we have to solder the components. This is what this is the soldering by using the lead, 25 watt lead iron bar, what you call soldering iron we are using. For ICs and micro chips, you have to use the 10 watt soldering iron. This is the 25 watt soldering iron we are using for a simple circuit, bridge rectifier circuit. So this is the soldering process. Okay. Okay then. We should be careful. Now you need to he is showing that it is a component we have to bend in this way properly according to your size requirement. You have to bend the component and place it onto the board, and afterwards we need to solder it. After soldering, we need to cut the extra LED which is projected here by using the cutter. This is cutting tools, cutting the leads which is extra projected from this surface. Now you can see the track side and the soldering points. This is the input, this is the output. This is the component side. Now we need 2 wires for AC inputs and 2 wires for DC output we are going to get with this circuit. For that we are providing the wires. Okay. This is the load side also, we are connecting 2 wires. Yes. Okay, now everything we made nicely. Now we are making 2 holes for this wire to be protected against the cut. So in this way we are making 2 holes for the grip. Now you can see the purpose of that. Now this circuit is ready for testing purpose. Now the circuit is ready for the circuit testing purpose. Everything we done. We prepared PCB. Now we are testing. Transformer we connected to this circuit. This is the bridge circuit. The bridge rectifier which converts AC input into DC output. This is the purpose of bridge rectifier. The bridge, it is in the form of bridge. After this output, we will get a pulsation DC, continuous pulsation DC. This is the transformer which transfers 230 volts step down into 230 volts into, I think it is a 606, means it is a 12 volts we are providing to the input, AC input we are giving. This is the capacitor for blocking the DC component and allows the AC to the ground. Final test. We are using the multimeter to test whether it is working or not. This is the final test. So you can also use the oscilloscope for the output. Say this is what we say. This is 0 here. This is also not on. So because we are not switched on the supply, please switch on the supply. Now you see the output. What is there in the multimeter? This is, I explained you. The output is 8.66 DC voltage. We are in the DC. We are measuring the DC voltage because the output voltage is DC voltage. This is the rectifier circuit. we are measuring in DC. Because of this capacitor, we will get this kind of output at the oscilloscope, on the oscilloscope screen. This way we need to test our circuit with the help of our oscilloscopes and multimeter. Thanks for watching. Please subscribe.